The last part of our unit is graphing systems of linear inequalities. So today we're just going to talk about how to graph a linear inequality. No systems today. So just like a normal equation of a line, we'll graph this just the same, but instead of an equal sign, you will see inequality signs. And just like with equations, your solutions are whatever makes the inequality true. Okay, so first thing today is how to test whether a point is a solution. So select all of the ordered pairs that are solutions of the following. So your equation is 2x minus 3y is less than 15. And we're just going to test each of these numbers. Okay, so let's start with 2, 5. The first number is x, and the point in the second number is y. So I'm going to take my equation, my inequality, and instead of putting x, I'll put 2. And instead of putting y, I'll put 5. Okay, go ahead and multiply. And we're going to subtract 4 minus 15. That would give me 11. 11 is less than 15, so that works, which means that A is in fact a solution. Okay, let's check B. Instead of x, I will put -1. Instead of y, I'll put -7. Multiply, so that would give me -2. -3 times -7 is positive 21, so we're going to put plus 21. That would give me, if I add those up, positive 19 is less than 15, which is false. So this one is not a solution. Okay, last one. I'm going to put 0 for both x and y because that's what it says up here. For the point. Okay, that would give me 0 minus 0, which is just 0. 0 is less than 15, so this one works. So C is also a solution. So that's how you test your solutions, just checking and seeing if it works and makes the inequality true. If it doesn't, then it would be not a solution. The big part about today is graphing inequalities, or graphing linear inequalities. So you're going to make sure that your equation is in slope-intercept form, which, remember, that is the form y equals mx plus b. So I'm going to give you some equations in standard form. If they're in standard form, you need to move them into slope-intercept form so that you can graph them. Okay, you're going to use a dashed line if it's less than or greater than. So if there's no line under the equal sign, just kind of like we had open and closed circles during first semester. It's going to be a solid line if you see that line underneath. So less than or equal to, greater than or equal to, because it includes everything on the line. Okay, and then this is also has shading, just like when we did inequalities first semester, you drew an arrow. This time you shade. So you will shade above if it is greater than and greater than or equal to. You will say shade below if it is less than or equal to. Onto our first graph, y is less than -1/2 x plus 4. All right, we're graphing this just like we've done before. This is already in the y equals mx plus b form. So I know my slope is -1/2. That's nice negative. So it goes down 1, right 2, and it starts at the point 4. So we graph it at 4, and notice that each square is worth 2. Because that happens on both the x-axis and the y-axis, it's okay to go ahead and do the slope as it says. So it starts at 4, and that's where 4 is because you have to look at the numbers. Goes down 1, right 2. Okay. Okay, now look at your signs here. It is less than. So because it doesn't have that line underneath, you need to make a dashed line. Literally like this. Okay? And now, again, because it's less than, numbers get less going down. So look at your y-intercept. Your y-intercept is at 4. We went less. So below that, it goes 2, 1, 0. It's going to get smaller. So because we went less than, we shade below. And if you want to shade in like highlighter or something, if you have a highlighter of your own, that's always a good idea for this unit, because then it's easier to see when we get to systems. So I shade below, and that is my linear inequality. Next one is a little different. It is in the form, it's a special line, y is less than 2. So this is really similar to the line y equals 2. Basically the same. So I put a point at 2, and I'm drawing a horizontal line through it. But here's the thing, it's less than. So I need to draw a dotted line because it's not equal to 2. It has to be less than 2. All right. And because it's less than, numbers get less than 2 going down. So when you see less than, you shade below the line. Like that. That's it. Last thing, this one is different because it's in standard form, and as I told you on the front, if it's in standard form, you're going to have to move it into slope intercept form. So we're going to take this equation, and I'm just going to I feel like I'm running out of space, so I'm going to write it out here. We need to get this solved for y. So the first thing we do is move the x term. It's being added, so I subtract it. Okay, so that means my new equation is 2y is greater than or equal to 8 minus 4x. Then I divide by what's in front of y, which would be 2. And now I simplify. 8 divided by 2 is 4. Negative 4 divided by 2 is negative 2. So here's my equation. It has a slope of negative 2, which means it's going to be negative 2 over 1. It goes down to right 1, and it starts at 4. So starting at 4, go down to right 1. And let's check our signs. It's greater than or equal to. So because it has that solid line below it, you can go ahead and make a solid line through the points because it's or equal to. And now to shade it, it's greater than or equal to. So because it's greater, numbers get greater, shading above. Here's my tip for you. I always start at the y, my intercept. So I'll start here. Numbers get greater, that's 4. Numbers get greater going up. Another way to think about it, if you already know you're shading above, which you should, this is kind of hard to see which way is above. So I go whoop this way, and that would be this section. So this would be above the line, greater than or equal to. That's it, folks.